Hello everyone, welcome to BHARGAV SUBS. So yesterday we had discussed the conditions for method of images and what is method of images. We discussed the basic definition and some important points regarding method of images and the conditions to be applied for the method of images. In this class, now we will discuss the procedure we have to follow in the method of images. The procedure means we have 5 or 6 steps, so we have to follow the method of images procedure to find the potential. Correct? So let us take an example and execute the how we can follow for the method of images procedure. So I am considering a plus q charge. Okay, I am considering a plus q charge here. So I am taking here plus q charge and I have to find the potential at point P. Correct? I have to find here potential at point P. So the potential at point P is not only depends upon the charge present here, but it also depends upon the charge distribution on the conducting surface, right? So what we are doing here, we took a charge and there you took a point. We have to find the potential at point B due to this plus q charge. So what we will do in the first step, a grounded metal plate is placed in front of the point charge. Okay, initially you have to place a grounded metal plate. Okay, so the grounded metal plate I took a grounded metal plate. It placed in front of the point charge. Later what is there? Negative charges are appear on the plate as induced charge. Why negative charges? You know, this is a conductor. Correct? In conductor there are free electrons. Total conductor present, there are free electrons. In this conductor contains free electrons. No, as this is a positive charge. So the both will attract. The positive charge and negative charge will attract. So it contains on both sides of the conductor the free electrons present. So when the positive charge is placed in front of a conducting sphere, so due to the attraction of the positive charge, the negative charges will move to the one side in where the positive charge is present, on the side of the positive charge. So there is a induction of negative charges on the side of the positive charge, this side. Correct? So placed. Next, what we have to do to calculate the net potential, a short technique was used, and the introduction of plate gives the effective potential on the surrounding points. Okay, so effective potential means the potential due to the plus q charge and potential due to the negative charges induced on the conducting surface. Correct? So this is the effective potential, and V plus V minus means the potential due to the positive charge and potential due to the negative charge. And next step, to calculate the net potential, a method was used. A sort of technique is called method of images. Correct? The method of it is the method of images where it is a technique to solve this kind of problems. So the electric field lines are drawn on the plate such that produce displacement vector on its surface, so that we will draw a vector field lines. Correct? We draw a vector field lines such that it produces a displacement vector. We know that from Maxwell equations we have a displacement vector formula. What is the displacement vector formula? D bar is equal to epsilon naught E bar plus P. This is the formula for displacement vector in the electrostatics. Correct? So here the polarization is 0. You know, polarization is 0. Why? It contains free electrons, free charges. For a conductor, there is a free charges. So polarization is 0. But if you use a dielectric medium here, in place of conducting sphere, if you use a dielectric medium, then the polarization is not 0. The polarization is 0 in the case of conducting surface only, because there are free charges contained in this conducting surface. So that's why here P0. So you will get D bar is equal to epsilon naught E bar. So displacement vector is directly proportional to the electric field lines. Correct? Displacement is directly proportional to the electric field lines. So due to this negative charge also, there is a creation of another charge, which is, let us move on to the next step then. So here D bar is equal to sigma n cap. Okay, so this sigma is known as free charge density. This sigma is known as free charge density. Correct? So density, so what is free charge density? See, there are generally two components in method of images. One is normal component, one is tangential component, perpendicular component. Due to the free charges present here, yesterday I told you two conditions. Among that, one condition was the tangential component is 0. because the tangential component is parallel to the surface. Okay, due to the free charges it was 0, but there was present a normal perpendicular component where the displacement takes place, electric field. So here only the tangential component is normal perpendicular component is present in this method of images. Okay, so that's why D is equal to sigma n cap, correct. So this is the free charge density. So d bar is directly proportional to the E bar, displacement is directly proportional to the E bar. Now we will draw a electric field lines through this surface. Okay, so we will go to the second step and let's see what will happen. Coming to the second point, what is the second point? In order to find the potential at a point, the slope of electric field lines of forces. So the slope of electric lines of forces recreated by an equivalent image as created by the dipole. So what they given? The slope of electric lines of forces means what? The direction of electric force is represented by the electric lines of forces. So if you want to find the direction, you have to draw electric lines of forces. So let us draw the electric lines of forces on the conducting surface. These are the electric lines of forces. Okay, and the direction is towards the conducting surface, and the slope of these electric lines of forces means how it was aligned on the above the surface will give us the rate of change of potential. Okay, del V is equal to minus E. So rate of change of potential is denoted by the slope of these electric lines of forces, and the potential at point P is depends on the configuration of this electric lines of forces. Okay, like how it was present, how much slope it was present. So this potential depends on the slope. That's the about second point. In order to find the potential at a point P, the slope of the electric lines of forces is recreated by an equivalent. Like these electric lines of forces is recreated by the image charge. How this image charge was present? When a single charge is present above the conducting surface, above the grounded conducting surface, so it was grounded. So if the conducting surface is grounded, okay, if the conducting surface was grounded, then if a single charge was present, then there is a creation of opposite charge on the opposite side of the conducting surface. So there is a creation of opposite charge, which was minus Q. Okay, if the conducting surface was grounded, then there is a creation of opposite charge of minus Q on the other side of the conducting surface. So you can join these. Okay, so after joining this we will get like this. So these are the direction of electric lines of forces. So that was told by this statement. Okay, created by the dipole. What is meant by dipole? If the two charges, either plus Q or plus Q minus Q, like two charges plus Q and minus Q are separated by a small distance d, then there is a formation of dipole. Correct? So this electric lines of forces slope determines the potential at point P, the rate of change of potential at point P. So rate of change of potential at point P will depends upon the configuration of the electric lines of forces. Okay, so this image charge distribution will give the dipole that creates a potential at point P. Now coming to the third point. So if the dipole is chosen, there comes a perpendicular plane where the potential is 0. So finally we got a dipole. This is plus Q and this is minus Q. With this dipole, there is a separation between a small distance d. For example, if the dipole is chosen, there comes a perpendicular plane. This is a perpendicular plane now, like it is a conducting surface. So the perpendicular line was created. So such that potential is 0. For see, if you consider a dipole, what is potential be? 1 by 4 pi epsilon naught Q r dot P by r cube. This is the potential for a dipole, correct? Where P is the dipole moment. P is equal to dipole moment. So dipole moment, what is the formula? Q into D. Okay, dipole moment is equal to Q into D. R dot P. What is R dot P? RP cos theta. So B is equal to 1 by 4 pi epsilon naught Q of Rp cos theta by R cube. 1 R gets cancelled, so R square. So V is equal to 1 by 4 pi epsilon naught U into P cos theta by R square. Okay, where theta is the angle between R and P. Okay, where theta is the angle between R and P. So here cos theta, what is if it is a 90 degrees, like it is aligned at a 90 degrees to the conducting surface, 90 degrees now. So if it was 90 degrees, then what is the potential? 1 by 4 pi epsilon naught U P cos 90 by R square. Correct? So cos 90 0. So finally you will get V potential is 0. Correct? So potential of the dipole moment is 0. It creates a perpendicular surface, like equatorial plane, which has potential is equal to 0. That is the meaning of the statement. If the dipole is chosen, there comes a perpendicular plane. This is considered as an equatorial plane between the conducting surface, where the potential is 0. So potential formula was for dipole moment was given. So we chosen a cos theta. Like R dot P equal cos theta, Rp cos theta. What is the angle here between conducting surface and the potential? 90. Cos 90 is equal to 0. Cos 90 is 0 now. So like orally potential V is equal to 0. That's the meaning of this statement. Okay, there is a creation of perpendicular surface where the potential is 0. Now coming to the third one. The plane of 0 potential is similar to the potential on the grounding metal plate. Okay, so what is the meaning of this sentence? Correct. The plane of a 0 potential is similar. The plane of 0 potential is in plane of 0 potential is this is dipole. Okay, so the plane of 0 potential is similar to the potential on the grounded metal plate. So what we got for this dipole movement, like potential for this dipole V is equal to 0 we got. So this is equal to this is similar to the potential on the grounded metal plate. So similarly here also the potential is 0. Why? You know, it is grounded. Why the potential is 0 for dipole plus Q and minus Q, both will cancel out each other. Finally, like there is a charge distribution equally, so you will got 0. Here on the metal surface, conducting surface, the potential is 0 because it was grounded. So if it is potentially 0, then only it is possible to create a opposite charge at equal distance, like same distances above. It will create a same distance below opposite sign of charge. Okay, if it is grounded, then only there is a possibility of creation of a charge which was opposite sign of the previous charge on at a same distance from the conducting surface. Correct? That's why the potential of the dipole and the potential of the equatorial plane. Dipole is considered as an equatorial plane. Similarly, the potential of the conducting surface is also equal to 0. That is the meaning of this statement. Similar. What are the similar? Plane of 0 potential this and potential on the grounded metal plate. Both are similar. And fifth point. If the image of the electric field lines are compared between the grounded plate and dipole, they are similar and equivalent. So what is the meaning of the statement? The electric field lines there now originated plus Q. Okay. Actually, the electric field lines appears to terminate on the conducting plane for a real case. But for mathematically, if you consider it as a mathematically, you have to draw like same electric lines which terminates at minus Q. Okay. So if the image of electric field lines are compared between grounding plate and the dipole, okay, between this and this plane, they are equivalent and similar. Actually, it starts at plus Q and terminates at minus Q, right? So this imaginary lines you have to draw. Either the dipole is real or imaginary, whatever the case. Either if it is real or imaginary, you have to draw the electric field lines which terminates at minus Q. Thus the potential at any point can be determined by adding the potential due to the dipole. So for scalar quantity, if you want to find the total potential, you have to apply the superposition principle. Correct? If you want to find the total potential, you have to apply the superposition principle. So if you want to find the total potential, potential V is a scalar. Okay, potential V is a scalar quantity. So if you want to find total potential, you will apply superposition principle. Superposition principle means what? You are adding the individual potentials. Okay, you are adding the individual potentials. Means V1 plus V2. You have to add both the potentials due to plus Q charge and both the potential due to minus Q charge. Okay, potential due to plus Q and potential due to minus Q. So you have to add both the potentials. Okay, V1, V2. So finally the output and the potential at point P will be V1 plus V2. Right. You know, potential at a point due to a charge is given by formula V is equal to 1 by 4 pi epsilon naught Q by, so if it is due to plus Q by, if it is a distance R1, okay, if it is a distance R2, so R1, this is the V1, right. Now potential due to V2 is equal to 1 by 4 pi epsilon naught minus Q. Now this charge was minus Q, so minus Q by R2. So these are the two potentials. Now if you want to add both, how you will add? Total potential V is equal to 1 by 4 pi epsilon naught Q by R1 minus, so minus Q now. V2 is there is a charge presence minus Q. So minus Q by, so minus 1 by 4 pi epsilon naught Q by R. So finally you will get 1 by 4 pi epsilon naught Q by 4 pi epsilon naught 1 by R1 minus 1 by R. So this is the total potential. Okay, total potential at point P. You understood? You understood the total concept, total procedure regarding method of images. I think you understood. I hope you understood. Yeah. So this is the procedure regarding finding the potential at a particular point due to a single charge. If there is a present. Okay, this is known as method of image. Thank you.